Welcome to the normal distribution. Some ideas that we're going to talk about first of all is obviously the graph of the normal distribution. Super important to know what it looks like and how it works. The empirical rule, finding z-scores from percentiles, finding probabilities and percentiles, and checking for normality. First of all, I've kind of got the graph and the empirical rule here in one spot, right? So the empirical rule, or the 68, 95.1, 99.7 rule, whatever you prefer to call it, says if we have a normal distribution which looks nice and bell-shaped and symmetric, right? Those are our words to describe her. Oh, there it is. Oh yeah, that was a normal curve. Says that if we go out one standard deviation, so we start at the mean, and we go down a standard deviation and up a standard deviation. Look, that's 68% of the data. If we go out two standard deviations, we get 95.1. Three standard deviations is 99.7. This doesn't come up all that much because we have normal CDF at our disposal, which I'll talk about in a second, but we should know it. Oh, there's the graph. Silly me. The normal distribution is bell-shaped and symmetric like we just saw. It's mean, median, and mode are all right there at the center, right? The mean, right here. The median is also there because the distribution is symmetric. Remember, symmetric distributions always have their mean and median and mode all are at the same spot. Not the mode, the mean and the median. Since the peak is also at the center, that's why the mode is also there. The mode, I don't care about it. If you need to sketch a normal curve, make sure to label the mean, three standard deviations up and down, and slap one of these things on there. All right, remember doing that? So like 50, 52, 54, 56. Just draw yours way better than I'm drawing this one. So draw it better than that, but that's roughly what you would do if you need to draw the normal curve. Z-scores from percentile. So suppose I want to find the location of the 75th percentile in a normal distribution. You're going to use the inverse normal feature in your calculator. Remember, the inverse normal feature only finds percentiles, so it will only find the area this way. If for some reason you need the area that way, you just find this and do 1 minus it. All right, the inverse normal function in the calculator gives you the z-score of a percentile. If you put 0 and 1. If the mean is 0 and the standard deviation is 1, it's going to spit back a z-score. If you put the mean from your distribution, say we did the one from mine, put mu as 50 and standard deviation is 2, it's going to actually give you the observation for the 75th percentile rather than the z-score. So if you need a z-score, 0, 1. If you need an observation, put your mean and standard deviation. Probabilities and percentiles, we're pretty much experts at this, but it's going to be normal CDF. Make sure you label the lower, upper, mean, and standard deviation. Same thing with the inverse norm. Make sure you're labeling the area, the mean, and the standard deviation. You have to label what those are if you're going to use your calculator speak. If you wanted percentile, so not instead of the probability between -3 and 7, you want a percentile, you remember you're going to need to do this. That needs to be your lower bound. That way you go out that way forever. Assessing normality. Given a set of data, then a normal probability plot in the calculator is how you're going to check for that. And you enter the data. Hello, random bug. You're going to enter the data, and one of the plot types you can choose is a normal probability plot. If the data is approximately normally distributed, the normal probability plot should be pretty much linear. Now, we don't use that method that often. What we use more often is we rely on the empirical rule. Because the empirical rule says 2 standard deviations out, I've got 95% of the data. So if I can't go 2 standard deviations in both directions, this data can't be normal. For a sample of 42 rabbits, the mean weight is 5 pounds and the standard deviation of weights is 3 pounds. Which of the following is most likely true about the weight for the rabbits in this sample? Well, the mean is 5. The standard deviation is 3, so 1 standard deviation down is 2. And I don't think there's such thing as a 0-pound rabbit. So I can't go more than two standard, it's probably like what, 1 2/3 of a standard deviation. So here's my 0. This can't be normal because I'm not going more than 2 standard deviations below the mean. So for the standard deviation to be 3, oh, that was bad. My finger bumped. This has to be skewed. And it's going to be skewed to the right because that's where the tail is. Let's see. Actually, I think it specifically says right there. The distribution of the weights is skewed to the right because the least possible weight is within 2 standard deviations of the mean. That's it. The commuting time for a student to travel from home to college campus is normally distributed with a mean of 30 minutes and a standard deviation of 5 minutes. If the student leaves home at 8:25 a.m., what is the probability the student will arrive at the college campus later than 9 a.m.? Okay, so what we have to think about is this distribution is talking about commute time. So we're talking about the student leaving at 8:25 and getting there later than 9 a.m. So we're talking about a commute time greater than 35 minutes. So basically, I want to find the probability that the commute time is greater than 35. I'm going to do a normal CDF to do that because it said normally distributed. If it's not normally distributed, you better find another way to do this problem. The lower bound is going to be 35. The upper bound is going to be infinity because it just says greater than 35 minutes. Hopefully she gets there eventually, though. The mean is 30. And the standard deviation is 5. And then I'm going to go to my Hand-Eye-Dand-Eye, TI Inspire, CAS, TI, sponsor me. Statistics, nope. Yeah, statistics, distributions, normal CDF. Lower bound is 35, upper bound is infinity. I'm just going to press a bunch of 9s because I don't feel like finding infinity right now. 30 is the mean, standard deviation is 5, and we do that and we get a probability of about 0.16. I'll go 0.159. And that's the answer. Let X represent a random variable whose distribution is normal with a mean of 100 and a standard deviation of 10. Which of the following is equivalent to the probability that X is greater than 115? So what I'm going to do is I'm going to draw it. So I'm not going to perfectly label this because I just need to get an idea. 100, 115 is right here. And this probability means this. Right? So we're going to... all of these are going to basically be taking advantage of the symmetry, right? That's what we're looking for, something that symmetrically gives me that same amount. So the probability that X is less than 115, well, that would be all the rest of this, right? So that'd be all of this. That's clearly not the same. So that's not right. The probability that X is less than or equal to 115, that's the same answer as A. The probability that X is less than 85. So 85 is down here. That's 15 below the mean. That's looking numerically equivalent, right? That's about the same shape. I mean, it's not perfect because I didn't draw it right, but that's looking pretty good. Let's look at the other ones just to make sure. The probability that X is between 85 and 115, that's the white space that I have. Clearly, that's not the same. E says 1 minus the probability that X is less than 85. 1 minus the probability that X is less than 85, that'd be everything but this, right? That's the same as A again, at least numerically. I don't know why I circled it. Pay no attention to the fool that circled it. The heights of adult women are approximately normally distributed, about a mean of 65 inches with a standard deviation of 2 inches. If Rachel is at the 99th percentile in height for adult women, then her height in inches is closest to... I have a percentile. I want an observation. Oh my goodness, I get to use inverse normal. I love using inverse normal. The area is 0.99 because it's the percentile. The mean is equal to 65. And the standard deviation is 2. When I do that in the calculator, TI, you should sponsor me. 65 and 2. I get 69.65, which seems pretty darn close to 70. Wait, what? He's already done? But this video is only 10 minutes.